This lesson is for FST, Lesson 1.5 on cumulative distributions. A cumulative distribution will give students a running total of the distribution, and that definition is listed in your textbook on page 39. We need to do a quick review of what frequency is before we can get into cumulative distributions. When you're working with frequency, that's simply how often an event occurs. So you're just basically saying how frequently something occurs and you're counting how many times that happens. To turn that amount into a relative frequency, you simply do the percent of the frequency. So you do the percent of how often an event occurs. And so when you're doing that, you want to take your frequency and divide by the total. When you do that division, you'll get a decimal, and you'll just turn that decimal into a percent. One of the new items that is in the reading is the word percentile, and the official definition is on page 40. Basically, to illustrate a percentile, I want to look at two quick examples. One of the ways you can use your percentile is in relation to your score. On a 20-point quiz, what score would you need if you wanted to be in the 80th percentile? So what that does is it compares you on a 1 to 100 scale if you want to be the 80th person in that list. So what score would you need to beat out 80 other people in a room of 100? So you're just going to take the number of points and multiply it by the percentile as a decimal. So think about that percentile like a percent. If you change it to a decimal, it would be 0.8. When you multiply those together, you get 16. So if you want to be in the 80th percentile for your score, you'd want to get at least a 16. Typically a percentile is going to mean that number or less. So if you get a 16 out of 20, that means in theory you would have beat out 80 other people who took the quiz. Another way to deal with a percentage question is to relate to how many people. So if you have 30 students taking a quiz and you want to be in the 30th percentile, let's figure out how many people you would have to beat. So if there's 30 people, and you multiply again by your percentile as a decimal, you'd get 24. So if you want to be in the 80th percentile, that would mean you'd have to score better than 24 of the 30 people. If you have further questions on percentiles, please check out page 40. But most of the time, when you're asked to calculate a percentile, it's related to one of the two examples you just looked at. As far as cumulative distributions go, we're going to look at question number 1 in the homework as our illustration of all the things that students need to learn cumulative. So let's read through the first question. Students need to note as well that the teacher will hand out a handout or a worksheet of problems 1 through 4 to help assist with the tables. Question number 1. Since 2003, the World Health Organization has tracked new cases of the avian flu or bird flu. The table below gives the number of people who have contracted the disease each year. Add columns to the table to show the total number of people who have contracted the disease at the end of each of the given years, the relative frequency, and the cumulative relative frequency. I've already added in those extra columns for students, so they don't have to worry about making those changes. Keep in mind that the years that are given are there, and then the next column that's given is technically the frequency. So 4 people contracted the disease in 2003, 46 people contracted the disease in 2004, and so on. So if we needed to do the relative frequency, we would do that in the next column. And for that, since we just reviewed relative frequency previously, we know that it's the frequency divided by the total. So let's go ahead and get the total. You add up all these numbers, you end up with 351. So to get the relative frequency, I would take the number of cases and divide by the total. When you do that, you'll get about 0.01. So we're just going to leave it that way. So students hopefully would know that that would either be read as 0.01, 1/100th, or 1%. All of those answers would be perfectly fine. This particular answer will lend itself to students being able to give the answer multiple ways, so we're going to leave it in decimal form. So for the remaining pieces here, we'll just take the number, divide by 351, and indicate the result. We are rounding to the hundredths place. So I'm going to go ahead and fill in the rest in fast forward motion here. So you can see the remainder of the relative frequency values here. If you were to add all of those up, you should get the number 1 for 100%. The next column, we're going to do the cumulative frequency. So we're going to ignore the blue column that we just made, and we're going to go back to the original frequency values. And all we're going to do is keep a running total of who has the disease, rather than just indicating who has it in each year. So the first number is going to remain the same. The second number is going to come from the first 2 years added together. So for your notes, it might be helpful to say 46 plus 4 there to help you remember where that number came from. Then we take that 50 and we add it to the next value. And so on. So I'll just fill in the rest of the values here. And our last thing that we're going to do is find the cumulative relative frequency. There are 2 ways that students can handle that, so let's fill in the title first. So for the cumulative relative frequency, we're going to take either the cumulative numbers here in green and divide those by the total, or I can take the relative frequency numbers and add those up as I go. So know that you have multiple options for getting that thing completed. I'm going to try to show some work for both methods. The first one's not going to be very interesting. It's just going to be either 4 divided by 351 or 0.01. So it's going to remain the same. For the next one, I can either do 50 divided by 351, or I can take the previous 2% and add them together. In either case, I'll get 14%. I'm going to go ahead and fill in the rest of the amounts here in fast forward motion. So now you can see the finished numbers. Again, the fraction came from taking the green values and dividing by the total. The decimal numbers came from taking the relative frequencies and adding those up as we went. So then the final results are there. I'm going to help students start question number 2 as well, and then they need to complete the rest of the table on their own. And then the remaining answers will be available on Moodle. A teacher gave a quiz with a maximum score of 20 points. The chart below gives each score X and its frequency F. How many students took the quiz? If you notice here, the X's are the scores and the F is the frequency. So what you would need to do there is add up the F column. So if you add all of those numbers up, you end up with 50 students. So if you need to, write yourself a quick note here that to find out how many students took it, you'd add the frequency column together. How many students score less than or equal to the 92nd percentile? So to figure that out for the score, the maximum score is 20. So you would take 20 times the 0.92, that's the 92 percentile in decimal form. And when we do that, we get 18.4. And so that is the score that they would get. And how many students we would need to take the total number from part A. So I apologize, I went in backwards order there. The number of students would be 50 times the percentile as a decimal. And when you do that, you get 46. So if students want to be in the 92nd percentile of a 50 student class, they'd want to do better than 46 of the other kids or get a score of 18. Next, students need to draw a cumulative frequency graph. So let's go ahead and fill in the cumulative numbers. So I'm going to do that in the next column. I'm just going to abbreviate it CF for cumulative frequency. And so remember that a cumulative distribution is a running total, so you just add the frequencies up as you go down the line. So the first number is going to stay the same, and we do 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 1 is 5, 5 plus 3 is 8, 8 plus 9 is 17, and so on. So I'm going to go ahead and fill in the rest of what's here, and then we'll start off on the relative frequency numbers. So you can see that the cumulative frequency values have now been filled in. To go ahead and draw a graph of that, I'm just going to give students the idea for how to set it up. They should do it on their homework paper on a piece of graph paper. Remember that the x values here are scores, and the y values is always the frequency or the relative frequency. You can see that the frequency goes up to about 50, so you'd want to gauge your scale appropriately to make sure that you can accommodate all of those values. So you'd indicate your scale, and then you'd go ahead and use the x column on your x-axis and the cumulative frequency values on your y-axis. And then you're just going to get dots. And you do not need to connect them, just indicate each coordinate. So the first one should be at 7, 1, the next coordinate should be at 9, 2, the next coordinate at 12, 4, and so on. The next thing you're going to do is the cumulative relative frequency graph. Students have the option here of either taking the cumulative numbers and dividing by 50 and getting a number there, or they can find the relative frequency numbers and then add them up as they go. So students may or may not use both columns here. I think I would do the cumulative relative frequency the fastest and the easiest by just taking these numbers and dividing by the total. So just do 1 divided by 50 and I'd get a value there, 2 divided by 50, 4 divided by 50, and so on. So that's as far as I'm going to go with helping students on this lesson. If they have other questions about cumulative distributions, they can continue to practice them here in the lesson or come and see me during class.